Let's read a story for today about Let's Be Healthy. Matt loves fruit juice. He drinks 1/2 liter of juice. He shared his drinks to his friends. His friends drink 1/3 of Matt's drink. How many liters did his friends drink? So this is application of multiplication of fraction. And let's analyze how did it come up with multiplication. So we are already in solving word problems. Before solving word problems, let us know how to solve word problems. So we already discussed this, that first you need to think, know, plan, and solve. So you understand first the problem, you know what is asked, what are the given facts, the word clues, and the operation that you're going to use, and then you solve and state it in a complete answer using S of 1, equation, the solution, and then answer. Now, what are the keywords that we're going to use, or to know if it's multiplication of fractions, or to know if it's multiplication? So we have twice, groups of, or the word of, times, for each, groups, multiply, altogether. So those are some words that you know that we're going to multiply. So steps in multiplying fractions, again, just have to recall our lesson. Multiply the numerators, multiply the denominators. If the answer is an improper fraction, change it into a mixed number, and then express it in simplest form. You can only multiply the numerators and the denominators if the fractions are in a simple fractions. But if it is a mixed number or a mixed fraction, you need to change it into improper fraction before multiplying the numerators and the denominators. But let's answer first the word problem of Matt. So again, Matt loves fruit juice. He drinks 1/2 liter of juice, and his friends drink 1/3 of Matt's drink. So if you're going to write it, 1/3 of Matt's drink. So Matt has 1/2. Therefore, if you're going to write an equation, you're going to write 1/3. What is 1/3 of Matt's drink, which is 1/2 liter? So if you're going to solve that, we have what is 1/3 of 1/2? That 1/2 is that's Matt's drink. And when you say the word of, you're going to multiply automatically. So we are going to solve the problem by just multiplying the numerator. So we have 1 times 1 is 1. Denominators, 3 times 2 is 6. So his friends drinks 1/6 liters of juice of Matt's drink. Now let's have more examples. The recipe for making a cake calls for 4 cups of flour. Trina will only prepare 1/2 of the recipe. How much cup of flour will she use? In this given problem, because of the word of, here, Trina will only prepare 1/2 of the recipe. The recipe is 4 cups. For one recipe, it needs 4 cups of flour. But Trina will only prepare 1/2 of the recipe. So when you write it, it's going to be 1/2 of 4. So 1/2 of the recipe is 4 cups of flour. So you just have, if you're going to write the equation, what is 1/2 times 4? Now, since it's a whole number, the rule is you just have to put 1 as the denominator, then multiply the numerators, which is 4, multiply the denominators. If it's improper fraction, you change into a proper or a mixed number or a whole number. Let's divide. 4 divided by 2 is 2. There is no 4. There is no remainder. Therefore, the answer is a whole number, which is 2. There's no other fraction since there is no remainder here. So how much cup of flour will she use? Since she will be using only 1/2 of the recipe, then she will be using 2 cups. of flour to make it a complete answer. Next. Mary has 6,000. She spent 1/6 of it to buy a bag and 1/3 of it to buy a pair of shoes. How much money did she spend in all? So, Mary has 6,000. 1/6 of it, of 1/6 of it. What is it? That is the 1/6 of 6,000. So we need to find what is 1/6 of 6,000. So the word of is multiplication. To change it to an equation, 1/6 times 6,000 over 1. So we have 6,000 over 6. Then divide 6,000 divided by 6. The answer is 1, 6, 0. There are 3 zeros. You can just add 3 zeros. There is no remainder. Therefore, she spent 1,000 pesos for the bag. This is only for the bag. There's another problem. 1/3 of it. 1/3 of it. Of, which is multiply, of it, that's the 6,000. 1/3 of it is for the pair of shoes. So, we need to write another equation would be 1/3 of 6,000. Then the new equation for that, 1/3 times 6,000 over 1, we have 6,000 over 3. Divide that. Since it's improper fraction, we have it's 2, 6, no remainder, there are 3 zeros. Therefore, Mary spent 2,000 pesos for the shoes. So again, she spent 1,000 pesos for the bag and 2,000 pesos for the shoes. But the question is, how much money did she spend in all? So basically, we are not just multiplying here, but there is addition as an operation that is added to the problem. So all you have to do, how much money did she spend in all? So you add the 1,000 pesos for the bag and then 2,000 for the shoes. So we have 1,000 plus 2,000. The answer is Mary spent 3,000 pesos. So that is now the answer. 3,000 pesos. Next. A cupcake recipe calls for 5 cups of flour per serving. If Mrs. Dizon will prepare 4 1/3 servings of the recipe, how much flour will she need? So in every serving, it needs 5 cups of flour. But Mrs. Dizon has a lot of orders, so she needs to prepare 4 1/3 of the recipe. So, you just have to multiply 5 cups. So, you're going to write what is 4 1/3 of the recipe, which is the 5 cups per servings, or in every recipe. So we have, for the new equation, we have 4 1/3 times 5. And since it's a whole number, you put 1. Then this one we will make into a improper fraction. So multiply, then add. 3 times 4 is 12, plus 1 is 13. Let's change it. So 13 over 3 times 5 over 1. Then multiply the numerators. That is 15, 65, and then over 3. Since it's improper fraction, then you're going to change into a mixed number. So that is 2, 6, 0, 5, that's 1, 3, 2. Therefore, the answer for the 21, that will be the whole number, and the numerator, which is the remainder, which is 2, and then copy the denominator, which is 3. It's already in simplest form. Therefore, Mrs. Dizon will need 21 2/3 cups of flour. she needs more than 5 since she will prepare 4 and 1/3 servings. Let's have one last example. A boy has 138 marbles. 1/6 of it are red. So let's answer it one by one. 3/5 of the remainder are yellow and the rest are blue marbles. How many blue marbles are there? So let us answer each given. First, we need to find how many red are there. It says there that it's 1/6 of it. The word of it, the 8 there is the 138. So, meaning, what is 1/6? What is 1/6 of 138? That is for the red marbles. Let's find first the red marbles. So that is 1/6 times 138 over 1. So we have 138 over 6. Then let's divide because it's improper fraction. 138 divided by 6, that's 2, 12, 18, 3. Therefore, the answer is 18, there's no remainder. Okay. Therefore, the answer is 23 red marbles. So there are 23 red marbles. It says there also that 3/5 of the remainder are yellow. So let's find for how many yellow marbles are there. For the yellow marbles, we have 3/5 of the remainder. So it's not the 138, but how many marbles are there except for the red one? So let's subtract the 138 minus 23 because there are 23 red marbles. So we have 5, 1. Okay, so the remaining marbles is 115. So let's multiply so that we can find for the number of yellow marbles. So 3/5 times 115 over 1. So that is 5, and 115 times 3, it's 15, carry 1, 4, 3. So that's 345. Then let's divide now. 345 divided by 5, that is 6, 45, 9. There is no remainder, so the answer is 69. There are 69 yellow marbles, and the rest are blue marbles. So if there are 23 red marbles and 69 yellow marbles, the rest are blue marbles. So the question here is, how many blue marbles are there? So all you have to do, this is not just only multiplication, but it involves other operation. So we have 23 plus 69. Let's add that. 23 plus 69, it's 12, carry 1, 92. So there are 92 yellow and red marbles. So how many blue marbles are there? So we just have to subtract 138 minus 92. That's for the yellow and red. So we have 6 and then 4. So let me check. 8, 13. Therefore, there are 46 blue marbles are there. So basically, all of these problems involves multiplication of fraction with or without addition or subtraction. So this is how multiplication of fractions is applied in real life situation.